1 plus N2. Similarly, variance of M1 is calculated, and which is N1 into N2 or divided by variance of N4 into N minus 1 if N is equal to N1 plus N2 is even, and if N is odd, then the formula is N1 plus N2 plus multiply by 2 divided by 4n square. And also the for large n greater than equal to 25, we are considering m1 to same procedure that we are applying the normal test, and the test procedure for the normal distribution is z equal to m minus expectation of m1 whole divided by variance of m1, and which follows the normal distribution. So here same procedure or same test can be applied or can be written in the form of the contingency table. So how we can define? Here two samples are there, sample 1 and sample 2, and number of is now again in row wise what we will calculate. So number of observation greater than median we will write as m1. Number of observations for second sample we will write it as m2, and number of observation less than m we will write it as n1 minus m, because the sample we are knowing the sample size. So sample size divide minus m1, we will get n1 minus m1. Similarly n2 minus 2 m2. So what it is? This is nothing but the chi-square 2 by 2 contingency table. So here we can apply chi-square test with 1 degree of freedom. So here if the observation are greater than 5, automatically for test for median we can apply the chi-square test. But if the frequency is small, so what we will do? So here we will apply hypergeometric distribution. So here we will calculate mean and variance by or probability by applying the hypergeometric distribution. So let us take the example. So here the following are the speed in kilometer per hour at which the fifth passenger car was the timed at a certain checkpost, and data is given here. Now what we have to test? The test for the null hypothesis of randomness at the 5 level of significance. Also the median speed is given, and which is 59.5 kilometer. So here median is 59.5. So again arrange the data as a, if it is above 59.5 we will assign the value A, and if it is below 9 we will below 59.5 we will assign the value this B. So it is like this. So here setting up a hypothesis, again what will be the null hypothesis? The null hypothesis is sample is random, level of significance is 5%, which is 0.05, and here the median is 59.5. Therefore we will get the pattern of following run as it is BBB A BB. So here this type of run is there. Okay. Now here N1 is nothing but the 25, and again N2 is also 25. Now what is the V? V is equal to 20. 20 is nothing but the number of run, and hence what will be the test statistic? The test statistic will be, we will calculate it by applying the formula expectation of U, variance of U, and hence Z will be minus, so we will apply or we will calculate the value of Z, and Z will be minus 1.72. Again that what critical value or tabulated value of Z is 1.96 for 5% level. So what will be the decision? The value of calculated of Z is 1.72. So taking the mode, so 1.72 is less than 1.96, and so we can say accept the hypothesis and the sample is random. So this is the median test. Okay, then next test is for rank sum test. Now in first test we have taken the sign. In second test we have considered the run. So we have followed the procedure of, we have applied the run. Now comes rank sum test. Now before starting with the test, let us say what is the rank. Rank is nothing but, here also same the pattern of order statistic has been applied. Okay. Now here we are giving the rank to a observation. So here if the data of X is given, let us take the example only. So here suppose the data is 62, 61, 63, so on. Okay. Now from this observation, 61 is smallest, so I will give the rank 1. 62 is next smallest, I will give rank 2. 63 is third largest, so I will assign the rank third. So in this way ranks are given. Now if you will say, if the observation are equal, suppose now first, second, third rank I have given. Now next observation is 64, 64 and 64. So which is coming 3 types. So which is coming 3 types. Okay. So now we have assigned the rank 3 ranks there for 61, 62 and 63. Now I have to give 3 ranks again, 4th, 5th and 6th. So I will take the average of these 3. So what I will take the average? So 4 plus 5 plus 6 divided by 3. So it is 11 plus 4 and which is 15 divided by 3. So which will be 5. So I will assign the value 5 to each of these 3 values. So my rank will start from 5, 5 and 5. So in this way we can say, if the tie occur, we can break the tie by taking the average of the rank. So here also property of ordered statistic it's been applied. So now let us see the test. So first rank sum test is Mann-Whitney-Wilcoxon U-test. So here in non-parametric, this test is considered to be the best one. So why? So let us see the procedure one by one. So this non-parametric test for 2 samples was described by Wilcoxon and studied by Mann-Whitney. So it is called as Mann-Whitney U-test. So Wilcoxon has applied U-test procedure, and after that it has been modified by Mann-Whitney. Sometime this test is also called as U-test. So what's the procedure? So let us start. So let us see in the slide. Let x1, x2 up to xn1 is an orders observation. Order observation having the sample of size n1 from a population with density f1 dot, and y1, y2 up to yn2 be an independent ordered sample of size n2 from another population with density f2 dot. Now again let us combine and arrange the observation in order of the magnitude, and then to give the combined ordered sample. So under what will be the null hypothesis? The both density function of the both the sample will be equal. So now let T denote the sum of the ranks of the Y's and in the combined ordered sample. So under HO, the test statistic is U is defined in the terms of T as follows: U equal to N1 into N2 into N1 into bracket N2 plus 1 divided by 2 minus T. And also first sample should be less than second. So if T is significantly large or small, Accordingly, we will accept or reject the hypothesis, and for the large sample, we can apply the normal test. Again, u mu will be expectation of mu u, and which is calculated by applying the given formula which I have shown. So expected, we have to calculate mean and variance, and then we have to apply the normal test. Again, z will be u minus mu upon sigma, and which follows the normal with 0 1, so which is asymptotically normal, and here we can apply the normal test. But here it will be better if the both sample n1 and n2 should be greater than it. Okay, now one note is that asymptotic relative efficiency ARE of Mann-Whitney U-test relative to two sample t-test is greater than 0.864. So here sometime Mann-Whitney U-test is considered to be the best. You would be knowing for the normal distribution, this it is called as ARE, and which is nothing but 0.0955. Okay. So let us denote T denotes the number of the sum of the rank of y's in the combined ordered sample, and under HO the test statistic U is defined in the terms of T as follows, and we will calculate U, and here also N1 less than L2, and same will be there. Okay. So again the note which we were calling that according to the Mann-Whitney second, so we have talked why I have also told you that Mann-Whitney U-test is considered to be the best in the non-parametric, because when asymptotic relative efficiency was considered, the value which have came is 0.86, then which is better than t-test. Okay, okay. And next is, this test can be applied when the observation in the sample of the data are rank only. That is, ordinal data is taken into consideration and not the measurement. Okay. So here I have taken the example, and which is the best on the sample of 2 university, and 10% level of significance is considered, and the 2 schools have to test that whether the graduate from the 2 schools have the same average grade on the aptitude test, and data which has not been read, but let me say the first data is university A, data related university A, and second data is the data related to the university B, and the data is 50, 52, 56, 60, so on, and data for B is 70, 73, etc., etc. So here, so again, what's the procedure? First merge the observation and rank the grades, and also the sum of the ranks for each samples. So ranks for, so again the rank sum for university A is 74, and rank sum for university B is 136. Rank sum means the sum of the ranks, it is there. Note, it should note is considered. So remark, let me say there some remark. If there is tie, each value get the average which you are knowing. So let us repeat again. So for example, if 2 values for the tie for the third and fourth place is there, then both are ranked as 3.5. If the 3 difference would be ranked like this, 7, 8 and rank 8 and 9, then their all rank will be 8. So same thing which I have told earlier. So here the group for university A is considered to be the first sample, and the group for universities B is considered to be the second sample. So here just see the completely data. So I have given the rank 1 to 20, both, then next grade is there, means data was there, and here in third column I have specified from the data is from which university. So you will get completely picture from this. Okay. Now come here again, apply the rule or apply the procedure. Here also the group from one university A is considered as the first sample, when the sample differ in size, designate the smaller sample as a suppose. Designate the second. If the second sample is smaller than the first sample, then we have to assign for second sample as a first sample and the first sample as a second sample. Now let T1 is equal to sum of the first sample. So again under HO apply the test statistic, and which we are defined as U, and it is defined in the term of T as follow, and U is equal to this. Again here a condition is there, N1 is less than equal to N2 and so on. So here also I have calculated mu and variance, and here also I am getting large value of Z, and which is nothing but the 14.5. And immediately we will say, here, because at a 10% level the significance value is 1.645, and automatically we will say calculated value is greater than tabulated. We reject the hypothesis, and the median are same, and thus we reject the hypothesis, and we will say that the medians are different. Now let us take Krusal-Wallis test or H test. So here when two samples are taken into consideration, we have taken Mann-Whitney U-test. But if K is greater than 2, then automatically one modification test is there, Krusal-Wallis or H test. Krusal-Wallis H test is a generalization of Mann-Whitney U-test. Again, what it says, that it is used to test the null hypothesis HO, that K independent samples are drawn from the identical population. And this test is an alternative non-parametric test. So let us recollect the memory that in parametric test, F test has been applied for testing the variability, okay, and if there are two population,